I was touching up my my stuff there. So. Yeah, so let's take a look at this and let's try and break down and figure out what kind of things that we want to do. Because I don't know what exactly it is that I want to add, I don't know what more it is that I want to do. So there's a few things I want to do with my face. You can kind of see. Doesn't look like you can really read the temps very well. Let's do. Also, I don't think I like that. I think I want that. Right. Do I want that? I think I want that. So people can see the swap, how much swap I'm using, which is at 1%, which is not bad. That's actually pretty good for starting off and booting up OBS. I still haven't done a terminal browser yet. But I am looking into. I'm thinking about what more it is that I want to do, what features that I want. I need to figure out if there's like a good org mode. If there's a good org mode for Helix or even Tucknet. Then I would be happy. I also want to figure out the solution here as well. Right? This is a really nice algorithm for this distance, the longest distance. The longest distance algorithm is something that I want to do so that I can enforce the placement of these rooms and stuff, right? I do want, corridors as well as rooms. I could do a bunch of room placements, right? I could do a bunch of room placements. Then I could sweep through. I could do a bunch of room placements, then I can sweep through. Then I can sweep through all the pixels and see, like basically do a flood fill. If it has an ID of 0, then give it an ID of 1. And then you just keep on incrementing that. So you just kind of sweep through, giving everything an ID and then flood fill. Because then what I would do, I mean these are all things. Again, I want to make the visuals really dial in the visuals. So I need to go back to doing, because I think what I need to do is I need to go with snagging just like the edge distance, right? The dead edge distance. I think that's where I'm getting the big part, right? What I think I need to do is let's go back and take a look at the let's take a look at the take a look here and take a look at what we have so far. I really don't like this. I really don't like this. I don't like this shit at all. I like really don't like this. Because it's like super frustrating, right? So we have the DDA, we have the DDA algorithm. Push next intersection. Oh wow! This is actually really good at handling the documentation and stuff, the inner documentation, number 4, number 3, all that stuff. It makes it look like that expression, which is super cool. I do like that. I like that a lot. Same things like numbers and expressions. I'll have to think about it. So I also need to think about what it is I'm going to do with tungsten, too. So I want the carbide. Basically, I want like carbide, like carbide stuff. Since I'm thinking about it, let's go into tungsten and take a look. I have nothing here. So I want dots, I want fast dots. Because the things that I want, because I know for a fact I want like an I-32, say int me. We do things like this, right? Because I think I am going to do a lot of like int main, int floats, things like that, floats, doubles, things along those lines. I'm probably what could you do a lot of things with this, right? So like this is the thing that I want. So I want to have prims. I want to have prim. I want to have prims, enums, classes, structs. All these things are really, really important. Also operators, but I think operators is just going to be an operator definition, right? Anything that you state is going to have. So I feel like for all things, there's going to be, because there's going to be like the class. Well, actually no, I think all operator. I feel like operator overloading is going to be something that is very strict. I feel like the operator overloading is going to be less of, because I feel like operator overloading is going to be less dealing with, unwrapping symbols into functions, right? like the way that operators fundamentally function is different than functions. Yes, you have expressions. I know response, response, expert, right? You have a constant expression, right? You have things, and I think I want tungsten to just kind of almost assume constant expression whenever it's, because I want it to fully. I want the compiler to do all the work. I want the compiler to do more work, and I want the user base to be able to extend the compiler, so that when you have things like, then I want things, in here just do like in a window. So like printf, you have something. Instead of that, you'd have something like, and you would have something like, take one. 800, 600, you'd have something like this. You'd have like a pixel A is equal to C1. Hello, unknown coup. Hello. The magic of development. Indeed. C1 as, or some such thing, because I want pixels in A dot G, things along these lines, and like have this kind of feeling of, because I want structs and primitives to be fundamentally different. Yes, structs will have a lot of, because like a primitive is going to have the primitive system is going to have very, very, very structured like primitives are going to have like full. It's like, how do I want to make it happen? Like, how do I want to make? What do I want? What do I want tungsten to look like? Because I want to have like the type def and shit like that, right? Like I want to have, that. I mean, and it's not just that, but I also want to have, the I want types of values. I want to be able to do that. I want function pointers. I want function signatures as a type, as a value. I want a lot of these kinds of things. And I also want people to just be able to start writing code in a way that makes sense to them. I want to have, callability. I want to allow for callables. I definitely want to have, what is it? Why can't I think of the properties? I want to have properties. Because properties are really, really good. Properties are a lot of fun. So, like, I want to have these things, right? So, I just need to think about what exactly that syntax is going to be. Like, what is that going to be? Because I want to have something, like, you know, because I want to have something along the lines of like a trim, from test point, right? And in here it is like mem. Yeah. Mem equals, you'd have a memdef of, you know, is you have 8 yeah. Memdef, and then you have operator, and then in here you'd have plus, you know, because I feel like it should be like time for taking stuff, but you did like define. You'd have plus do things right. May can be GB primitive T prim T prim A T prim B. I mean, we could even say the T prim. T prim T prim A plus T prim B. Okay. You do this, right? To T prim. And it returns the T prim. And like this kind of syntax might be something very useful. Yeah. This kind of syntax. Yeah. Because then you're, you know, because you are defining, you're effectively defining the actual underlying instructions. Because it is, you know, RA, register A, you know, load load A into, it is, load A, you know, load A into R, load B into B, and then it is, you know, RA plus RB. And like this is the kind of thing that we're, because this is literally like the CPU instructions. right? Like that is what it is. It's going to be. And then it is, because you're defining the unit. Because like the way that operators work is that they take the left side, the right side, or just the right side, or just the left side, or whatever. They collapse the way they do things is that they collapse op plus to op plus resolve. Right. Because there's going to be a lot of things. Load A into RA. Load. Yeah. There's going to be a lot of this stuff. Like this is the kind of things that. Right. This just means that it's like unnamed. Because we could say, it is hash 8 or something. In here, because like if we have, say, like a prim A64. Unsigned 64, right? Prim. Something along these lines. There could be something along, there might be certain, like conveniences, right? Because it is a type of unit, right? U32 is, right? U64 is of type units, and this is like the category, right? Number 64, and then you can say, like there might be other things like that, right? It is a type of unit. Same thing with like a prim, like a prim byte is of type unit. And then this is so we have these things in a way that is very well done. Hello, Schmelly. Hello, Orc. How you doing today? Yeah, I just had some ideas that I wanted to possibly hash out in my mind, noggin. For tungsten, because I want to have like actually state how on the silicon level, like almost at the assembly level, what the like what kinds of things are, and I want the because basically what it could do is that the compiler could say, oh, okay, how wide is it? Is it the entire, A and B, right? It's like, what if, because this is actually, U64, U64. This is a U, right? Okay. Yeah, U64B to turns to U64 X. And then we can say might not even do that. To overturn. Because this is going to be the return. And this is basically just saying, hey, if you are treating, whenever you have a U64 on left, U64 on right, you're doing things, and then you're just like piping the information. And then this way, like operator overload is going to be very interesting, right? And then you also have, your U64. U64. And we have LVA into RA, load B into RA minus B. And then basically what this is doing is that this is the precedence. This is the precedence. Right? And you have other precedents. So the plus will be resolved first, then the minus, then the multiply, then the bitwise operators, then like all of that stuff. I think that a lot of the times, because you would also have something along the lines of, say, always have, 64. Well, I mean, this is unsigned. Let's do an I. Right. Because then you could do you could do these things, right? And you would have your RB, RA minus RB, or whatever. You'd load them into the registers, you'd subtract one, and then right. So you would have these in this way, and then and then effectively what you're doing is you're stating the bitwise operations and stuff like that, right? And then the compilers would just have to, you just update, and you would just update the compilers to have access to any new instruction sets or whatever for whatever your target is. And that's basically all that you do. And all that stuff. So it is effectively getting compiled down into an assembler, and then you would end up, because like this is like a pseudo assembly, but because I don't want to have like a massive assembly set, because like I don't want, because even the most like even the most like low-level language, programmer is not going to want to have to deal with a fat stack of garbage. And like basically what I want is to have, is effectively what I want this to end up being is just a platform for dealing with, because I just want hints, right? The int is a hint. This is an integer. This is a type of integer. This is a type of, this is a type of, floating point number. And that's much more for, like what the print function is going to be like. Because that's going to be like an intrinsic. Right, there's going to be like some set of intrinsic. Being able to extend what those intrinsics are is like a huge facet. It's going to be like a good starting point. But I want the compilers to be very, very, because there's like 3 different kinds of compilers, right? At least there will be in Tungsten. There's going to be some stuff, right? So you have your A O T, and what it does is it takes your src dot tungsten. Right? It takes that in, and then spits out your main dot basic, right? And this here, this is like your universal bytecode. And then what we have is your JIT and native runtime compiler. And what it does is it takes your .wc and an output, and then it outputs MC. And your executable. Or native machine code, right? NMC, right? Native machine code. And the only difference here is that on one side, now you have your JIT, or your NRC, right? Your JIT and your NRC. Yeah. And your JIT goes to your JIT goes to your CPU, and your NRC just goes to file. Right, that's the only difference. That it just runs it to native machine code, and it either goes through a JIT, which outputs to your CPU, or your NRC, which outputs the file. Right, that's the only difference between the two. They are effectively doing the same. Like, conceptually, they're doing the same. But in, like, asterisk, there's a lot more complexities to it. Asterisk, there's a lot more complexities to it. But conceptually, they are the same piece of software. They're the same thing. And they do the same thing. And that's mainly what I want to do. But another core facet is that I want the source, and I also want your interns, your source and interns go into your AOT. And like, that is the thing that I really want to maintain, is that you're being able to build your own intrinsics in the language, in the same, in your UBCs, right? And this is also .wc. Right? It could probably be better if I just did that. Right. And like, this is how the architecture is going to work. You take your source text. You take your source text. It goes into time compiler. It also takes in your intrinsics, as your the UBC intrinsics. Takes all that stuff in there. And it outputs to main, into the bytecode, and you can take that bytecode and pipe it through a JIT or NRC, and then that goes into other shit, right? Like, that's how it's supposed to work. So I want to be able to target these kinds of files. So we're going to need to have the concept of a header file, right? And what this native machine code compiler, what the NMC is going to do, right? Like the NMC needs to what it does is it takes things like, first it reads the universal bytecode, builds the definitions, it builds the def, builds the def tables, and then it will you know, and it'll translate. All right, and then it'll translate, and then from here we have here you have a decision tree, which is going to be J, I, T, or N, R, C. Right? And then here, okay, on the JIT side, it goes to your CPU for execution, or to file. It goes to the CPU for immediate execution, or it goes to a file, right? And this is the true distinction, because the JITs, right? The native machine code, it is running, so it has to do all this stuff. All of this needs to happen, regardless of if you're just in time or native runtime product, right? So when you're doing this, it literally doesn't matter when. It doesn't matter. Yeah. So the JIT is going to, the benefit is going to be that it is super, very, very good. But here's the really cool thing. Here's the super thing, right? Like, let's say you have, WD. So you have your dub dude, your tungsten dude. Someone makes Dune in tungsten, right? Someone makes Dune in tungsten. Dot EXE. Something that you could do, right? That you could just say, recomp. Done. Okay. And then what this will do, is it'll take, right, it'll take your executable. It'll take your executable, okay. And then let's split it up into, right? I'll split it up into your tungsten JIT, TJIT, and your WC. And then actually I'm getting this wrong. I'm saying this is an executable. This is a file. And then it runs this here to then output a new. Right? It's just a thing that all of these applications will be able to do. Right? Yeah, like it's just a thing that you can do. And that is the real cool. Because then you could also spawn a script that renames, because you can also do dash recomp dash replace, right? Because if you do the in place, right? Then, because like if you do the in place, you know, the recomp dash I, right, or something. If you do that, then what it'll do is that it'll basically just it'll spawn, you know, it'll basically just spawn a replace that at stage, and then it'll just, you know, rm or like mv, and then I'll just, you know, move doom.rc.exe to let's do an mv. Okay, and just be done. This is effectively what it'll do. So yeah, I'll just do that, and then that'll be it. Because like effectively what it can do is that it can effectively, because like it can either read it, or you could do it in the in place, and then it'll just spawn, you know, because like the JIT, right? The way that the file will be is that you have in here, you have you effectively can just have your NRC here, and then here you have your actual app data. So you can run this, and in fact you can just say, hey, take this and then output it to new executable. Right? You can do that. This is the thing you can do. Because effectively, like, there's no difference between the JIT and the NRC, right? Like, it's all just the same shit, right? The NMC. This is the NMC. The native machine code compiler. right? The native machine code compiler is just kind of defaults to JIT mode, and it's like fused like that. And then you can just explicitly set it to NMC, and then output it. Like you could just do that. Right? You can't do it in place on its own. You have to spawn another worker, right? You have to spawn like a new worker operation, and then you close the first one, and then you can rewrite and save over the executable. Like that's basically how you do it. You could do that, but it's also kind of like a pain in the ass, especially with like Windows, and Linux doesn't like doing it because that's literally malware behavior. So it would be kind of like an in-place update kind of thing, and then you could just like update it in place, and then you have a native. And then you just have a native system. Like it'll just work, like out of the box, right? It doesn't care anymore. Yeah, because then it could do because effectively all that you're doing is you're front loading all the definitions and stuff, and like how everything works, and then you're just executing all the instructions. And then the NMC, right? The NMC portion of it. You split it as a JIT, and then from the JIT, you do the NRC, and from here to. Right, like this is kind of like the flow path of how all that would work. And this would work great, honestly. Because it'd be like really, really interesting if like game developers could just be like, hey, here's my game, and you release it to a bunch of, you release it to a bunch of people, it gets shared, yada yada yada, etc, etc, blah blah blah. And then like if you're worried about like the loadout time, because I feel like something like games would have a lot of like big deaths and stuff like that, and it might take a significant amount of time to boot up and stuff. But if you're like worried about performance, and you want like the bleeding edge, highest performance, you could just recomp in place. Just recompile your game on your machine. So you don't need any extra libraries, you don't need any extra compilers, you don't need to do it. The game is the compiler. And you can just recompile it. It'd be fucking, and not just for color, and not just for games, but also like literally everything else. Yeah, more people. We got the Horde, we got the Unknown Co-op, we got the Use, we got the Skunker. Yeah, I was just going over, kind of taking like an hour-long break before getting back into current. I'm fucking I'm supposed to be doing some more tooling for her. I don't want. But it's only Tuesday. If I don't get on it soon, then I'm gonna be in trouble. But yeah, I don't know if you've heard it, but being able to, like, one of the things that I want to do for tungsten is make it so that it can, like, if you have your if you have a piece of software, you can just either run it as is, right? Like, you'd either be able to run it as is, or you could do a recompile. And it would literally take the executable, split it into the compiler and the source code, and then recompile it in place, and then be done. And then you immediately have huge gains in your like loading time gains and stuff like that. Like, you wouldn't have to worry about it loading; it would load instantly. And like a whole host of other like really cool properties would exist. So you have your native machine code compiler here, and then you have your and this is like a design. This is a design principle that I really want to double down. Being able to, I mean, doing the in-place stuff might not necessarily be something that you can do adequately. I might literally just make it so that we might be able to rename things while it's running. Question mark, question mark. I don't think it likes doing that though. But yeah, there's like a bunch of things you could do. But yeah, recompiling for your native hardware would be fucking incredible. Because you can make the you can make a because you can have like hardware specific optimizations. Because you can very easily do like very broad stroke, like you can do very broad stroke compilation and distribution for a compiler, or just like for any piece of software that uses, the quote unquote common core instruction set. And that's fine, right? But what you can end up doing, I mean, like there's a lot of other things you could do. Because I can make the JIT do, because what it would do is it would build the translation. Right? It would build this translation. Yeah, this oh shit. And it would build this translation here. It would build this translation library, this translation, and then use that as what it runs off of. So the JIT will probably have some issues with like it's probably gonna have some issues with like the instruction sets and stuff like that. Because I also want the because I want the UBC, because like the U is like the UBC is gonna have it's gonna be very generic. It's gonna be very similar to like Unicode and stuff like that, where you have, where if you have your, what is it, like FA, that's 1111 0100. And then what you can do is you could say, like, it can be very difficult to manage things. Like, you can say, like, how many bytes. There's a few different ways of doing it. The easiest way of doing it is you say, hey, I am an instruction. So you can say like E A F A. This ends up you have this side and this side. Okay. So this side gets broken out into 0, 1, 0, 0, 0, 1, 0, 0. And this side gets broken out into 1, 1, 1, 1. Actually, it's not 1. That's AA. EA. EA Sports. It's in the wallet. 0, 1, 0. Oh, wait, no, that's not. That is. Hold on. E. It's not. It's one less. Am I super dumb? I think A is the start. It's 16. Oh, anything past 8. Duh. I'm super stupid. I know binary. This should be 7. This is 7A. I know how to fucking write binary. This is 0, 1, 1. And then this is, what? 1, 0, 1, 0. There we go. That's it. 1, 0, 1, 0. Yeah, I know how to binary. And this one is 1, 1, 1, 1. 1, 0, 1. So basically what this says is, hey, this is saying, hey, I'm incomplete. So this narrows down, and within the first group, do some shit, right? Within group 7A, do some stuff. Cool. And then actually execute what you find. But what if you do something along the lines of like 7A, 6F, 90, right? What happens here? Here we have A, 6F, 90. 7A, 6F, 90. Here, what you end up having is, I'm like way over an hour, but I don't give a shit. What you have here is this byte representation. Becomes 0, 1, 1, 1. 1, 0, 1, 0. Right. This is the first group. Right. This is just group 1. Well, actually, I should do this. Alright, this is group 1. Right. And what this is saying, what this is actually saying, is this is essentially building, you know, this is saying, you know, not done with right, not done with instruction. Right. And then here, you know, what is this, 6F? So this is what, 0, 1, 0, 1, 1, 0. 0, 1, 1, 0, F is 1, 1, 1, 1. And here, we are still not done. Right, and then finally we have 90, which is 1, 0. Or I should say translate. Translate 6. Yeah, translate 6. 7A. Seven A 6 F. To machine code, right? And that's literally how it's going to be. And the way that the compiler is going to work is that it's going to be working towards like building this out. So this whole thing is one singular. Right? So we can say that this whole thing is one singular reader. And being able to do that, right, which means you can build arbitrarily large, execution tables, right? You can build absolutely massive execution tables. And you can also like drop out easy. And you can also like drop out early and do all kinds of crazy shit. Yeah. So like there's huge translation tables that they can build with this. And that's literally just like the point of it, right? Is that you can build enormous translation tables. Right. And that's literally the whole purpose. So you have this idea of like registers. You have register A, register B, register C. I might do like multiple registers or something along those lines. I might do kind of a loose ideology of what a register actually is. Because effectively I'm allowing people to write effectively writing assembly for tungsten. Right. For the tungsten bytecode. To define new primitives, to define new structures, to define new things altogether. Being able to define new patterns and things like that, like the difference between like a struct and a class. Like that might have a different, you know, a different ideology. Like I have no clue what the community is gonna want out of tungsten. You know, I'm just one person. I don't have fucking clairvoyance. You know, if I had the ability to see into the future, I wouldn't be unemployed right now. I mean, I probably still would. It's just that I wouldn't be struggling for money. You know, I'd own a house. And I'd be, you know, with my wife living off somewhere and, you know, enjoying a house that we have together somewhere, you know, and we'd all be happy. I wouldn't be struggling, with an unpaid fucking phone bill and shit on an old ass fucking computer. I mean, I probably still would. Because it can run on here, it can run on anything. Right. So, like, I have no idea what people are gonna want. And I think understanding that is critical. Because, like, a lot of it is that it's not just that I don't know what other people are going to want, I don't know what I'm going to want. Right? Like, I can't possibly know what every single little facet that I'm going to want. I simply can't. I do not have perfect knowledge of these. I'm eating my coffee today. I haven't passed it or a filter or anything. Can I do that? I'm gonna have to experiment with that. But I think there's a really easy way that I can filter out coffee without making a huge mess at least. Give me my phone. Okay. So, I'm supposed to be doing this work. I'm supposed to be working on it. I'm supposed to be doing spreadsheets. I'm supposed to be doing supposed to be doing glue, not drawing. I mean, I'm really, really excited about tungsten and coming up with a lot of the same. Just like a lot of the stuff that I want to do for it. So, and I think doing something along these lines, because I could also do so, like, the problem is that there's also, like, you could do some pagination. You could do pagination. But the problem with that is that if you treat, like, one way of doing it is you treat the first byte as an indicator of how long this instruction is. You know, like, hey, this is a 3-byte instruction, this is a 4-byte instruction, yada yada yada. Then you end up wasting a fat stack of information, which is telling you how big shit is. And I really don't like that. No, I just want it to be, hey, go until you see a 1 in the beginning. Like, sure, that means that you only have, 127, null byte null byte instructions, but kind of really big. That's kind of a lot. It's 127 null byte instructions. right? The 6502 only had maybe 200, if that. Like I don't know how many instructions the 6502 had. So the majority of things aren't going to have this. Like a lot of it is just configuring like you have a compiler configuration. You have a compiler configurator as part of the bytecode, basically, right? So you'd be defining a lot of this stuff. Type defs and things like that. So you'd be like, reads in the UBC, it builds the definitions table, the translation table, and then it translates it, right? So like it's effectively, so we can just do this. And this is like a huge thing. Like, this is still, 7 bytes per. 7, like that's a 21 byte number. Like, that's fucking huge. That's the 21 bytes. Like, it's huge. Like, it's way more than anyone's gonna use. Like, that's a massive fucking number. Right? That's literally 2 to the 21. It's fucking huge. Like, why? Fucking... Right, like... and yo... Okay, I don't care about the stroke order. Like, fucking for real, dog. Like, yo. Yeah. I think that's proper use. Yeah. I did it wrong. It's that. Oh, it's a little bit better, but that penman shit fucking sucks, so maybe that's like what. Okay, great. Alright. Yeah. And so I also like because I can do that. So I could also say like katakana, hiragana, and katakana, and deal. This nonsense. Something along those lines. So, I mean, this is like, and this is like, wait. this is way more than you're gonna need. Because you probably only need about like maybe 64 or like 92, something like that. Somewhere around there. Something like that. So having these things are, it's fine. 127 is fine. Like this is gonna cover the vast majority of cases, right? Like that's that's gonna be plenty. Mhm. Like that's gonna be plenty. Like that's gonna be plenty. Right? Like, yo, who needs more than that? So this should be fun. Right? I do want room to grow. Right? Granted, it's not going to be like a true system or something like that. I mean, and this is also going to be really interesting because I could embed this bytecode into. I could literally embed this bytecode into a JPEG. Because I'm basically going to be doing 2 projects in one. Because like this is a CPU emulator. That's how this is going to work, right? Is that it is a CPU emulator. Okay. So, I mean, that's literally how bytecode works in general. So, we have that. Translate that because this is set. Translate to machine. You basically stack, translate until the current instruction is done. Job's done. I think that is the non-unit I want to do. I'm gonna do that. So yeah. Right. So like this is the have to so again, I don't know. I want to do. Okay. So we get edge distance. Oh, I can't just boop it up. Oh no! Oh no! Hmm. That is working. That's working. I oh no. I like no. No, did I fuck everything up? I think I fucked it. I think I uber fucked it. Good to know. Monday. Why? Um, okay. They have the same thing, right? And then we do have that 11 instead. This is only working. Oh no, it is working on the... Ooh. Hey. You appreciate the lectures in between the going, yeah. Awesome. I'm glad. I mean, most of that is literally just lectures for myself, honestly. Because like that is something that I'm gonna be, like I am gonna be working on. Yeah. Like I'm gonna be working on a lot of that stuff. Because like I want to make tungsten. Tungsten is kind of something that I really do want to. Tungsten is something that I really want to make. So, yeah. Like, and it's also kind of a really big and scary. Like, it's a really big and scary project as well, you know. So why Monday? Oh, interesting. So anytime you have a corner, every corner is marked. Anything that is part of a corner is marked. Right. Because anything that is not solid, anything that is solid needs to have something. So, money. Monday. Fuck my ass wrong. So I feel like I'm not doing this very well, right? I feel like, yeah, I mean, I'm kind of in the same boat, because at this point I'm just bitch fucking around because I don't want to actually do work.
Time to stretch.
Yeah, everyone in chat, fucking stretch your ass. Come on. And also, honestly, I'm just gonna do this. Hmm. Maybe that worked. Not really. I just moved this. Making a monster character model for making the art renders will use those monster models for when you make the animations and they summon the actual cards. Yeah. Um. Well, I don't remember. I don't remember you saying that. No. You do make it. It's just. Oh no. Okay. Well, I'm gonna be right back. Dude, that's. I need to get myself some paper towels. I'll be right back. Let's do the. I saw it should happen. I knew this would be better. So I'll be right back. I got some cleaning left to do. I'll be right back. Okay.
I need more caffeine. My blood is not thin enough.
I'm gonna have a lot of grounds in my coffee. Come on. Oh, I will have to come up with a better navigator. I'm dealing with I cold brew in the future. I think I have a few ideas, but the biggest problem that I have is that I don't have a screen anymore. Right? Because if I had meth, right, if I had screen meth, then you know, if I had like a mesh screen, then like a fine mesh screen, and I could put that over it and do all that, and then like rinse it off and clean it out. That would be ideal. And it would basically just be a French press. I would also buy. So I feel like all this stuff is not very good. So let's do. This is like a terrible way of doing it. Because this is not very okay. So let's try and do something a little bit different. With a get edge distance. Yeah. So float to corner is a minimum of 1.0. Yada yada yada. Blah blah blah. I mean, honestly, I probably should just do it. It just makes more sense for you. What is it? What's not lining it properly? Oh, your graveyard. Yeah, what's breaking on them, yeah. So we get edge distance. So this is the function we need to. So we have the entropy. So here we have nothing. Nothing. Oh, it looks so bad without the edge detection. Like, this looks so bad. Holy shit, I didn't realize just how important it was to have that. Like, that's like super. Am I actually getting good noise angle? I almost feel like that's not even. That's so. Really subtle. I don't know. We have the. That. Um. Range. Oh. We could do all 4 cells. We could do all 4 cells. That's interesting. It's very interesting. I don't know if I could map that far. That'd be interesting. I mean, it'd be also really easy for me to learn to use as well, if I can map it properly. I'll have to look into that. Because I do have, like... Because I know that when I'm using... Like when I'm using stuff, when I'm using the tablet, so we could do all 4 of these cells. Northwest, northeast, southwest, southeast. If I am... Oh, and I also need to know what cell I'm currently in. I might not need to necessarily know the plane that I'm in. Question mark, question mark? I mean, maybe. Probably. Probably. Right. I really like the idea of having the X, Y, and Z, right? And then I just do the XY plane, XZ plane. XY, XZ, YZ. because I want because effectively what I want to do is that instead of a float T, I want to have a thing. Oh. 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 Ah. Ah. See? Ah. See? Ah. 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 Hello. How is your hi, hello, hi. Hello. How you doing? Oh, yeah. Yeah, Kern, I'm doing Kern. Hello, this is a 2D game engine, and I'm doing a 3D game. That's what this is. So currently what I'm doing is, I don't like how, so, I'll show you exactly what it is, that's wrong. So I can go up here. So I can do this, right? Yeah, it's a game that's built around the idea of using static to approximate grayscale values, and then I just kind of made more and more quality of life stuff. Is what I did. And now here, so this is, so I had solved edge detection, right? Because the textures don't look very good unless you can outline the edges, the corners of things. So the outside corners and inside corners and all that stuff. So we have all of this. And then, but I don't like how this looks, right? Like I don't like how straight and harsh it is. I want to have, and it's also very, it's not very generic, right? It's not very universal, and I don't like that. It's a very, it is a solution that can effectively only do these harsh edges. I can't tweak it, I can't modify it, I can't change how it looks, the shape, or any of that stuff, and I don't like that, right? So currently, oh yeah, and I can change that, and darken it, make it brighter if I wanted to. Super bright if I really wanted to. Oh, I think the fall off in the brightness is separate, which is nice. But yeah, no, this is a grayscale game. It can technically handle color. But currently, all the textures are procedural. No two bricks are exactly the same width. You can see, like, down there, these bricks are slightly different widths. The ceiling is all different stuff. I think I was telling you about it because of, what was it? Because of shaders, right? It was because of like shaders and stuff, and like Love 2D and shaders and something and another, maybe Tungsten. Telling you about my programming language that I'm working on, maybe. I can't remember. I've slept since then. Yeah, super awesome to see you in my stream. Hello, hi, hello. Yes. Yeah, because I remember you were asking me like a boatload of questions. A bunch of questions. And I was like answering them. But I don't exactly remember everything that we talked about. Unfortunately, and I apologize. I'm sorry. I know, I'm such a great streamer. I actually pay attention to it. Yeah, how did your stream go? How, you know, feel free to, like, drop links and stuff. I like shares. Yeah, so I don't like how that looks. So I want to change it. And I want to be very, yeah, so I want to be more, do something. Alright, so I can do this. So now, the top. Nande. Nani? What? Why is you not... Eh? Oh, yeah. Ooh, spawn-based Kirby platforms. Yeah, I mean, I feel that. I definitely feel that. Yeah, for the spawn-based Kirby platforms. Is that a fly buzzing around me? No, it's not. Oh, right, yeah, you were doing the, you were doing... What was it again? Yeah, you were doing stuff and things. But yeah, so I have the plane. But I'm getting the plane. PDA plane times 8. Oh, let's do not for now. Let's just do that. Wow, it helps if I don't blast everything out completely. There we go. Now we can see that that's working properly. I mean, you can't see the roof anymore. I mean, if you squint real hard, you still see it. Also, you can tell that one side is visibly darker than the other. Yes. Hello. Yeah, fighting against your own systems is a pretty common trope. Welcome to game development. A certain skunk in my chat wouldn't know anything about that, you know, blowing scope. Okay, we got the noises. Got the edge test. It's just 2. So that does. Cool. So, what is the next portion? So we know we want to separate, right? We want the X direction distance. If I know what's selling, for the sake of argument, let's say we are in, for the sake of argument, let's say that we know that we're right. For the sake of argument, let's just say you're here, right? Yo. I am not. Well, whatever. Let's just say for the sake of argument. I don't have. I have this. In what I want. And then I have. Oops. And I have. The ray has gone. Something like this, right? So our intersection point is here. Right. We have our intersection point. Now we know that we have the UV2. Oh, right. Our. No, I don't know. Somebody. Well, was it you that looked at my shader toy and was asking a bunch of questions like how the ray tracing and all that, or was that someone else? I can't remember. Somebody was asking me a boatload of questions on how, like, the raycasting, like how my raycast engine worked and stuff. I can't remember. I can't remember if it was you or somebody else. So if we have the intersection here, right, then we know what cell we need. And there's two different situations. One, situation A. Let's do a different. Shit. Situation A, that we have a thing next. Well, this is also inaccurate because if this is the case, then what we actually want is I actually don't want that. I don't like that one bit. There we go. That's a lot better. Right, so we have. I'm probably not. So we have our hit location, right? We have our hit location, and we have the cell that we hit, right? Now, what we need to do is we need to know the distance in the x-axis. How far are we from the nearest one? For one, we need to know if what we hit is because like this could also be like in the floor, right? It could also be like in here. Somewhere in here. We also know for a fact that the hit location is somewhere in here, right? And it is somewhere within here. We know for a fact that it's somewhere. Right. I can't really do Yeah, we can do that. So we know for a fact that the intersection point must live somewhere within this region. This declared region here must contain the intersection. Let's say that we're intersecting. What information do we need? Right? What does XYZ mean? What? God damn! Can I fucking English? I swear, I swear English is my first language. Okay. 私は日本語が少しわかります。No hablo español, mi amigo. Okay, like, and English is my number one language. I swear I'm gonna be able to speak computer 1001011110101 a lot more fucking fluently than English. Start speaking in ASCII. What does he actually mean? Do what does he actually mean? So here, the case one, right? So case one. So P dot X. Speak your mother. Speak to your motherboard with that now. That's a good one. Right, this is the distance. Oh. I mean, X, I only need to know if so the easiest. Well, let's do the easy way. Let's do an easy solution. That is, if, that is if either of these, right, because we have A, B, C, D. Yeah, I told him to make blackjack. He did not make blackjack. So here, right? But if this is actually on over here, it becomes this, that, and that. So there is a problem, and that is that if it is hitting a wall, this is fine hitting a wall, then this is going to equate to 0 regardless. Right. It's always going to. Over here, I mean, I could do the maximum. So it's always going to be at most 1. Right? Because anything outside of here, it's not going to. Like, at most, it's going to be 5. So I could do the maximum. It's either going to be 0. Oh no, I can still do the minimum. Because if it's over here, yeah. Oh, okay. It's the minimum of this and yeah, I think yeah, it's gonna be minimum of that. And oh yeah, some other raycasting stuff here. Yeah, but Sini, if you have this is A or C. Minimum of A or C times U V T dot X. Right? Should be something like that. And this needs to be clamped. So, actually,
time to stretch.
yes, stretch. Do the stretchies. Do the stretch overs. Nando. Yo, buddy. It's not. Thank you. Move this out of the damn way, buddy. Let's do myself a little bit. Oh, okay. And then this should be the same. Because X is just, because that is just gonna be the minimum of some shit, right? Monday. I mean, angels. So if I have this, right, then if it is A or B, then it is equal to, if it is A or B, so A, right, that's more stuff. So A or B times U, B. I don't know. I don't know any of them by heart, honestly. And then it is gonna be C or D. C or D. Oh, wait. No, I did this wrong. One plus one equals 5. No, it's 10 plus, it's 10 plus 1. 10 plus 1 equals 5. Because 101 equals 5. Some real. Now there's 10 kinds of people in the world. Those who understand binary and those who don't. Okay. T dot Z equal to the minimum. Yep. I was thinking with incomplete date. U V T dot Z 1 minus U V T dot Z. I think this is going to be the easiest. And then you just take the minimum over. Right. Then you reconstruct it, and then you can do this. So T dot x is equal to the minimum of, oh shit. So what is it? Because I need to get the cells. Right. So I need to like fetch the cells. What is it? Get color, get color. Mondo. Colors plain. Oh, right, this builds all that stuff. Yeah. This looks like fucking dog shit, you know? Yeah. Yeah. That's definitely the right one. get some. Int get some. Should be 1. Yeah. 1 or 0. Monday. Wait, why is this not? Why? This guy is throwing out. No, it doesn't. Monday. And why the fuck do I have that? Yeah, just return the integer. Oh, this is equal to that. Equal to that. Oh, this is get cell too. Return int value. Okay. I'm a fucking dumb fuck. That's what I am. Whoops. That's not even the right guess. This gets it. Okay, so that does returns integer, the value is greater than 0. Where was I? Okay. There is a buggy on my shit. Almost looks like a mosquito. What happened? Yeah. Alright. Alright, Skeeter. I guess it's so. A little bit hard for me to read, though. Which is only slightly a problem. What the fuck was I doing? Oh, I'm darkening it up just a touch. Let's do kind of readable. Means that the actual text itself is, which is something that I not want to do. When the fuck did that happen? Okay. So we have this, which means that we need to get the. Let's just do. Okay. So we need. I got to. Min cell is equal to the minimum cell is equal to the minimum cell is equal to the round of the hits minus 1. Max cell is round hit. And then well, the when you get cell, and then cell. Cell. I have 2 and X. Next, so 1 2 2. We have this, and t dot x is equal to minimum of the int of the pool. Actually, I think is there's a lot of things that I really don't like, because in newer versions of GLSL, you can just I don't care. Yeah. You can just evaluate it integers as booleans. But the early versions of GLSL doesn't actually have integers, it's all floating point numbers. Which is, you know, right. Yeah. I'll do that. The minimum of integer b d times 1 dot minus UVT dot x A or C times UVT dot and then I mean, I might be able to just go. That's fine. Times UVT dot. That's fine. UVT dot. Fine. Nope. Oh no. It's different. A or what is it? Cell. Here again. Probably broke something. Round is not a thing. Round is not a real. Not convert from constant float to temp pool. None there. I vector. I vector. Pool. Monday. Sure. Okay. Then. So that is that, right? Ah, yeah. So that is the actual distance. And then what we do is we do a little bit of Swiss. T is equal minimum T dot Y Z X G dot Z X Y. That should. Ah, perfect. Oh, glorious. Yeah, perfect. Okay, cool. So that does work perfectly fine there. And there's a little. Okay. So, making progress. Do I want to go until 10 or do I want to go until 2? That's like another 15 minutes, right? 10 after? It's not too big of a deal. Not too. Okay. What is the fourth root? Wait, the fourth root of 4. Alright, fourth root of 4? I mean, it should be the same, right? We are the same. Yeah. So there is a fundamental problem, my assumption. Kind of. So the big thing, if there isn't something, right? If there isn't. I mean, that still would. It's all zero. And it's like zero all over. But it should be. Let's take a look at what this can do, right? So 0, 0, 0, there's nothing there. Now what does this look like? I think those. There's like a huge discrepancy. This is actually. That is fine. But Monday. Wait. Huh? Oh. There's nothing on this side. That's not what we want. We want not. Interesting. I'm gonna have to figure this out. So the cell if because there should be an easy way of doing this, like very interesante. Very interesante. Let's see. We have a bit of a. But no matter what, we are detecting until the edge. But what we actually are not, whether or not that direction is different than right? So how do we find there be X or cell? X or E. Alright, is that a thing? So or E. This is fine. E is equal to what is X? What is X in GLSL? GLSL X. Do 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 do. Do 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 do. Do 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 do. The Skunko is live. Do I still have people? I do still have some people here. GLSL. GLSL. Operator, what is it? Number. The absolute value of x minus 1. Interesting. Get interesting. None. Oh, no. Okay. Wait, but I should get. I should be getting. Yeah, this is just the internal. That is... But it is not. What's that do? do the maximum. But, interesting. Very interessante. Yeah. Very interessante. ¿Por qué? ¿Por qué? ¿Por qué? I do not understand. Yeah, so we have the is go here. Yeah. I need to get monetized in order to do that for myself. But it is at 3 hours, so I am gonna end it here. I do have a bit of a doobly doo with the doobly doo. And I have something I'm going to want to do. Haha, lol. Come on. I mean, I'm sure you should be able to take a while, yes. I don't know who it could possibly be. Oh, I think if I just do... this. Wrong. Ready to raid in sometime. Tap to raid now. Come on.